Good evening. Hi, everyone. We're so glad you joined us for Whitebark Pine, a species worth protecting with Erin Shanahan with the National Park Service. This is the third talk in our series called Under One Canopy, Celebrating Trees and Forests. If you'd like to watch a recording of one of our previous talks or get more information about some of our upcoming events, please visit our website at www.gallatinvalleyearthday.org. I'm so thrilled to see you all here tonight, and I see almost all our chairs are full, but there are more in the back there for the latecomers who want to grab another chair. And I also wanted to welcome all of you who are joining us online tonight. We have quite a few. My name is Ann Reddy, and I am the chair of the Gallatin Valley Earth Day Committee. I can't wait to hear Erin and hear what she has to share about Whitebark Pine tonight. But first, I need to thank our sponsors. Our whole series is free because of the support, the generous support from many local businesses, government agencies, and other organizations in our community. I would like to thank our fiscal sponsor, which is Greater Gallatin United Way, and our premier sponsors, the City of Bozeman, Volkswagen of Bozeman, Audi Bozeman, and our benefactor sponsors, Sacagawea Audubon Society, our local radio station, KGBM, the Montana Parent Magazine, and Bozeman Greenbuild, along with our stewards, Bridger Bowl Ski Area, Happy Trash Can, and Gallatin Wildlife Association. And of course, all of our community volunteers who help make all our events happen. Without their generous support, we would not be able to bring you tonight's program. And I'd also like to give a big shout out to the Hope Lutheran Church. And now onto our program. Before I introduce Erin, I just wanted to let you know that there will be a question and answer period after her talk. If you're joining us online, if you look at the bottom of your screen, there's a little Q&A. If you click on that, a pop-up window will appear. You can type in your question, and our tech person, Rich, will read your question to Erin. If you're in the audience, just raise your hand. I'll bring a microphone around. That way people online can hear your question more clearly. Now I guess I'm very honored to introduce Erin Shanahan. Erin is an ecologist for the National Park Service, Greater Yellowstone Inventory and Monitoring Network. She has been the protocol lead for the interagency Whitebark Pine monitoring program since its inception in 2004. Through her work monitoring Whitebark Pine, Erin has had the privilege to visit some of the most magnificent areas throughout the Greater Yellowstone ecosystem. And also we have a special surprise tonight. We have a special guest, and I'll let Erin introduce him. So now if you can just please join me in a round of applause, and I'll thank Erin.
Thank you very much. And our special guest is Kyle Marvany. He works for the U.S. Forest Service, and he also worked on the Whitebark Pine program for 4 years with us. So he knows a lot about what I'm talking about. And he will tell you all a little bit about the Little Bear Seed Orchard that is just over the hill at the end of my presentation. So yes, I work for the Greater Yellowstone Inventory and Monitoring Network. And for those folks who, can everybody hear me okay? No?
Get it up a little. Yeah.
Bend it into my mouth. Yeah. Okay. So is that better? It's like touching. It's okay. It's fine. So I work with the Inventory and Monitoring Division, and we are a part of the science branch of the National Park Service. There are 32 I&M networks across the country. And each of these networks, we service a suite of parks, and they are grouped geographically and also by the natural resource characteristics that they all have in common. So, and within 280 of the currently 423 parks or monuments or historic sites, the INM monitors a select group of ecological indicators, or what we call vital signs. And by tracking these vital signs through time, we get a better understanding of the health trajectory of not only that resource that we're tracking, but other resources that share the same environment. So for example, oh, did it work? Okay. I work for the Greater Yellowstone Network, so the red circle is where we are, and we work in these 4 parks, so Bighorn Canyon, Grand Teton, the Parkway, and then Yellowstone. Some of the other 31 networks, they might have anywhere from 15 to 20 parks that they work in, but we have some heavy hitters here. So we have Yellowstone, and that is 2.2 million acres. Teton is 3,000, I think it's 310,000 acres. So a lot of it's about capacity. Some of the other parks are just an acre. So our vital signs for the network I work in are whitebark pine, upland vegetation, and then amphibians and water quality. So what I decided to do tonight was I'm giving people an opt-out. So I'm going to do a pachachka, or maybe you call it a pechakucha or whatever. But these are really popular like 10 years ago, but I know they still do them here in Bozeman. So this is whitebark pine in a nutshell. So for those of you who have stuff you want to do, I'll get it done in 7 minutes and you can take off. You won't get to see Kyle. I won't be offended, but anyway, here we go. And so this is set on a timer, and I'm going to use my cue cards. I used to have this memorized. This is like the 12th time I've given it because they're so hard to put together. And I just feel like I need to do this like 20 times so it's worth the taxpayer dollars that went into the building. So, okay, here we go. Okay, and again, I put this together in like 2012 at the end of the mountain pine beetle outbreak, so it's a little outdated, but I'll do my best. If you've had a chance to drive, fly over, or hike around any of our western forests in the past few years, I imagine you might be somewhat alarmed by the number of dead trees you see. Many forests no longer fit our perception of what a healthy forest should look like, which for the most part is green or some shade of it. Now we see a different color. Now there's a lot of brown in the forest landscape. Trees are dying by the thousands for a variety of reasons, and of particular concern in the Greater Yellowstone area are those iconic high elevation stands in the upper reaches of the ecosystem. Many of these areas are dominated by whitebark pine. Whitebark pine is one of 5 stone pines worldwide and is the only North American member of this exclusive group. Stone pines have 5 needles per needle bundle, indehiscent cones that remained closed, and wingless seeds. As a result of their cone and seed morphology, stone pines rely on other species to spread their genes. Whitebark pine is considered a keystone species at treeline and in subalpine environments due to the critical role it plays in shaping biodiversity in these areas. It is a food source for a variety of wildlife, acts as a nurse plant by enabling other species to establish in otherwise intolerable habitats, and helps regulate soil and snow processes. Mature cones of whitebark pine are oblong and about 5 to 8 centimeters in length. There are about 200 to 250 seeds per cone, and each seed weighs about 175 milligrams. These seeds are an energy-rich food. They are some of the largest compared to other conifers in the region and are high in fat, calories, and protein. As previously mentioned, whitebark depend on other species to disperse their seeds, and the Clark's nutcracker is the primary disperser. Because this particular bird is required for effective seed distribution, whitebark pine have evolved some unique features specific to the bird. This specialization minimizes harvest competition and allows nutcrackers to leisurely extract copious amounts of seeds with their sharp, long bills. Cones are conspicuously positioned on the tips of upper branches for easy access. Birds can fill their throat pouches with up to 60 seeds at a time. They will fly as far as 14 miles from the tree to stash multiple seeds in a cache on the ground or in the crook of a tree branch. One bird can cache an estimated 35,000 to 98,000 seeds in a good cone crop year. There are several secondary dispersers, including the red squirrel, which cuts entire branches from the tops of the trees, collects the fallen cones from the ground, and then stockpiles the whole cone in a midden on the forest floor. Few seedlings will sprout from squirrel caching because they typically bury them too deep, but occasionally you may come across a few. However, red squirrel middens enable other species to gain access to these otherwise unreachable cones. There are over 20 vertebrate species that utilize these cones. The most notable is the grizzly bear. Population data suggests that in poor cone production years, there tends to be higher bear mortality and smaller litter sizes. Bears may also go into the den with less accumulated body fat. Much of the debate surrounding the recent loss of whitebark pine is related to the grizzly bear and its controversial listing status under the Endangered Species Act. Essentially, the two elements at the core of this deliberation are whether grizzly bears are dependent on whitebark pine as a food source, and is whitebark pine truly in peril and potentially beyond recovery. Well, I don't think it's a stretch to say that most people have a visual image of what a healthy forest should look like. Lush, full, green canopy with straight trunks. When you look at the forest to the right of the slide, they just don't look right. And clearly, from a bird's eye view, many Western forests are looking like the photo on the top right. So what's up? The problem stems from a variety of sources, but for whitebark pine and pure and mixed forests, we mainly talk about the fearsome four. The exotic fungus white pine blister rust, native mountain pine beetle, altered disturbance or fire regimes, and climate change, with blister rust and mountain pine beetle as the most immediate threat to the persistence of whitebark pine on the landscape. White pine blister rust is a non-native fungus that was introduced in the early 1900s to Vancouver from infected nursery stock. Throughout its life cycle, blister rust is transferred back and forth from the tree to one of several intermediary hosts. Infection starts in the needles and over time travels down the branches and eventually to the trunk. The orange bubbles are Acacia spores in an active canker. The sap that the tree produces in an attempt to stave off the infection and the Acacia spores themselves are sweet to the taste and attract all sorts of rodents, porcupines, and insects. As they feed on the infected area, the bark and the inner tissue of the tree is stripped away, resulting in girdling of the infected branch or trunk. This girdling stops the flow of nutrients, and any portion of the tree above the damaged bark eventually dies. Mountain pine beetle infestations are rapid and intense. Within as little as 2 weeks, an attacked tree can be functionally dead. Beetles mass attack a tree, then feed on the soft tissue under the bark. When entering the tree, they release blue-stained fungus stored in their mouths. The combination of the blue-stained fungus and larval feeding pattern stops the flow of essential nutrients throughout the tree. In epidemic proportions, mountain pine beetle can quickly turn a forest canopy brown. Which leads us to the question, is whitebark pine doomed? Before you come to your own conclusion on the fate of whitebark pine and high elevation forests in general, you have to consider the whole picture. A whitebark pine forest is not just the upper canopy, but the sum of its parts. If you spend time walking and exploring beneath that canopy, you're sure to notice that many of those dead or dying overstory trees are sheltering a healthy, regenerating understory community. Yes, there has clearly been a disproportionate loss of larger trees, but there are hundreds of seedlings and saplings waiting to take their place. And all that newly accessible sunshine has the potential to speed up that transition. As we have witnessed from the devastating '88 fires, forests do return. We are currently 35 years post-fire in Yellowstone, and a few summers ago, I had the misfortune of having to hike and navigate through an old burn for about 14 miles. The trees were about 12 to 15 feet tall, thick as dog's hair, and the forest was teeming with wildlife. Essentially, we have front row seats in this opportunity to observe and experience basic forest succession as it takes place in real time in our own backyard. Admittedly, there may be some challenging adjustments for certain species, but one can only hope that those individuals that persevere will be that much stronger for their struggle. I really encourage you to form your own opinion as to the fate of whitebark pine in our Western forests. But to do this, you'll need to get your body and your minds up to those awesome high mountain forests and see for yourself what is happening both in the canopy and on the ground. I can say with confidence that Clark's Nutcracker does not always remember where she stashed seed number 21,568. So, okay, that's my PK. Okay. Great. I'm gonna retire it once I give it 8 more times, so if you have any parties or whatever, call me, I'd be happy to. All right, so who cares about whitebark pine? I've spent most of my early career before I had a family working as a wildlife biotech. So, and what I find really interesting is, you know, when I worked on bears or cougars or whatever, whenever I met anybody and I told them what I did, I instantly got this like, really, you know, and questions, and they were engaged, and it kind of gives you a big head actually. So when I started working on vegetation and particularly a single tree, people really glaze over pretty quick. So it's just been a really interesting dynamic to me. And in fact, I have my brother and sister-in-law are here from the East Coast, as is my mom, but I have another brother back there who still thinks I work on bears, and I haven't worked on a bear project since 1998. And I think part of it is because he thinks it's cooler to say that his sister works on bears than on a tree. So that's why I'm guessing. So, but what I want to stress to folks is I think everybody should really care about trees and vegetation in general, because as this food web shows by the crest people, trees and green plants are really the foundation of life. So if you care about any of these charismatic megafauna, the bears, the wolves, you really need to care about plants, because plants support the animals that those animals eat. So, and some people will go as far as saying that soil is really the most important thing. So, but I'm going to go with trees and whitebark pines right there. But really, shifting to another phase is Indigenous and First Nations peoples have had a strong connection with whitebark pine for centuries. So they've used whitebark pine for nutritional purposes, medicinal, and then also for strong cultural values. And I'll get into that a little bit farther in my presentation. But more from an agency standpoint, so many of you have probably heard of the Greater Yellowstone Coordinating Committee. It was established in 1964. And it was comprised of a group of federal and state land superintendents. And this group enabled federal and state land managers to basically come together and to pool resources to work on a common purpose and towards a common goal on a landscape level. And in the late 1990s, the early 2000s, the GYCC recognized that whitebark pine was a key component in our high elevation forests, and they wanted to get a better understanding of the population health status. So the GYCC is an umbrella, and it has 9 subcommittees underneath of it. And the whitebark pine subcommittee was established in 2001. And the first members of it were both from the National Park Service and U.S. Forest Service. And the mission was to help ensure the long-term viability and function of whitebark pine in the greater Yellowstone ecosystem. And then later on, the BLM, the Bureau of Land Management, and then folks from the U.S. Fish and Wildlife Service joined. And now we have a whole host of other people. We have some NGOs. We have the Department of Natural Resources. We have American Forests. We have the Whitebark Pine Ecosystem Foundation, folks from MSU, and then other private entities. At the same time that the subcommittee was formed, the Whitebark Pine Ecosystem Foundation came into being. And this group, there's some overlap between the folks on the subcommittee. So a lot of us are members of the foundation, but it also has a lot of university researchers, other just private citizens. They're always happy to take members. You can go on their website and join. But this group is absolutely amazing to me. This picture was taken in 2001 at their first meeting. And so many of the folks in that photo are they're retired, and they're still so engaged in whitebark pine. They are out there just trying to get interest in it. They all work as chair members on the committee. And also, I guess, they're so willing to share their knowledge. So I know a lot about the piece of whitebark pine that I work in, but there's so much I don't know. But I know who to call, and these people are always more than happy to pick up the phone and help me out. So I'm super grateful to work in this community. They're wonderful people. So just real quick, I'm going to do a little bit of describe some characteristics of whitebark pine. the little tree 101. So there's 7 common subalpine higher elevation pines or conifers in the GYE. So we have Doug fir, Rocky Mountain juniper, subalpine fir, lodgepole pine, Engelmann spruce, and limber pine. And then we have whitebark pine. So whitebark pine can grow erect like in this picture, but more often than not, it grows in these like real twisted forms. So it's not really commercially useful. They can't make a straight 2x4 out of a whitebark pine. Plus they're really hard to get to. So there's not a lot of commercial value. The bark is flaky and it's got a whitish hue, so that's the name. They have long needles and they're in bundles of 5. And then they also have these really squat, dense, purple, browny, sappy cones, and they're positioned on the tips of the trees. They're also found typically above 8,500 feet. So there's a couple trees in our ecosystem you could get them confused with. Lodgepole pine are also a long needle pine, but they only have 2 needles per bundle. Whereas again, whitebark pine have 5 needles. The one that's really hard to tell the difference between is limber pine and whitebark pine. They grow similarly. They both have 5 needles. They're really hard to distinguish. There is an elevational gradient. So typically whitebark's above 8,500 feet, limber's below, and then limber also is found on more limestone soils. But really the only way you can tell the 2 apart, aside from collecting some needles and sending it to a lab, and it costs like $20 per sample, is the cones. So on the left-hand side, we have limber pine cones. They're long, they're pretty big, they're green. They open, so their seeds will come out. Whereas whitebark pine, again, indehiscent means that they don't open. They just remain closed. Something has to pick them out. And you'll see remnant cones on limber pine, like the ones, those are just old cones and they'll stay up there. You rarely ever see an intact whitebark pine cone because those seeds are so valuable to wildlife. So most of them get picked out and you might just see like a little skeleton on the top. Very rare would you ever see a full one. So again, cones are the most reliable, only reliable in my opinion. Also in early part of the season, you have male pollen cones and they are different colors. So they're lime green on limber and they're more this pinkish. They're really pretty on whitebark pine. But as the season goes on, they start to senesce or they get old and then they start looking the same basically. So that's not totally reliable. So again, elevation is not a reliable hint of what species it is, nor is substrate. And then they also, because of the way the nutcrackers cache these seeds, so they'll get, nutcrackers would use limber pine as well, but they cache them in the same little hole. So this might look like one tree, but it's probably more like 6 trees. So you'll see each trunk goes down into the ground, and that's really from all those seeds growing up together. And so limber pine, they grow the same way. We have a site that's down. So the farther in latitude you go down toward in the south, the higher you'll find limber pine. So we have a site down in the Salt Range, and it's over 10,000 feet. And in a cache like this, there's a bunch of trees coming out, and there's actually a limber pine and a whitebark pine side by side. So the bird obviously stashed seeds of both species in there. So elevation is not a good hint. Okay. So the other thing I did, all the background slides are places that we go in the summer, and I put the names of where they are. So if anybody's really curious about some of these beautiful places, come talk to me. I'll tell you, I can tell you all sorts of fun spots to go. But this is in the Green River Lakes. Beautiful place. So let me catch up with my notes. So why is whitebark pine a species worth protecting? This is the distribution of whitebark pine in the Western US and in Canada. And a lot of spots where whitebark pine grow in the US are actually in protected wilderness. And 56% Jill of whitebark pine are actually, the range is in Canada. So Canada has a lot. Again, whitebark pine is a foundation or keystone species in high elevation ecosystems where it helps shape the biodiversity of these subalpine areas. It's a very slow growing tree. It's hardy. It's a hardy, cold adapted pioneer that is shade intolerant. So it really likes to be in the full sun. And because of these unique physiological traits, It's really well suited for establishing early in harsh windswept mountainous environments like we have out here in the Mountain West. And what happens is whitebark pine gets into these mountainous areas and it establishes a foothold. This allows other less resilient or shade tolerant species, or those that can grow in a shady environment like alpine fir or Engelmann spruce. These species come in and then they flourish under the protective canopy of the early establishing whitebark pine. So they also, once they get in there, they ameliorate the soil and the soil properties, which makes the growing environment much more friendly for these later arriving species. The tree islands that they create on ridges and in these exposed areas, they provide surface area or like roughage. And as the snow is blowing across those open sites, it traps snow in those islands. And then they have really deep root systems. Like lodgepole pine are super shallow, and that's why they tip over all the time. But these guys have super deep roots. And actually the other thing is that that's why you see them standing so long after they've died. It just takes them a long time to fall over. And these roots help stabilize the soil. And that in turn helps reduce erosion. And as the snow melts, you know, we don't get as muddy rivers as we would, I guess. So lots of ecosystem services they provide in these high elevation sites. They're also, again, a really useful food resource for lots of animals. And then back to this idea of a vital sign. So essentially they act as like the canary in the coal mine for other high alpine species that share the same habitat, and also for just general ecosystem function. So if whitebark pine are doing poorly, it's likely that other species that share their habitat might be doing poorly as well. So back to indigenous peoples have used whitebark pine for food. So the seeds and the cambium. They also use parts of the tree to brew for teas. Medicinally, they use the needles and they make a cough syrup out of it. And they also, the sap is used as salves. And then from a spiritual point of view, it really connects indigenous peoples with the mountains. And it's also an important resource for the animals that are represented in a lot of their spiritual and ceremonial practices. So it's very important. And then again, we've got the animals that use whitebark pine. There's 13 kinds of birds. There's 2 types of bears, squirrels, brown squirrels, a couple species of chipmunk. And then as the birds are pecking the seeds out, some of those seeds just go winging off, and any kind of little mouse or whatever is certainly going to pick it up. So I want to talk real briefly about the bear. So we used to think when whitebark pine was really getting hammered early on in the early 2000s, you know, we always thought that the grizzly bear survival was tightly linked to whitebark pine cone production. But whitebark pine are a masting species, which means that they put out a ton of cones one year and then not so many the next couple of years, because what they're doing is, you know, they put so many resources into putting a ton of cones out. So then they kind of like go back for a couple of years and they're just building back up again. So in those lean years, the bears are obviously eating other things. So they, you know, they're a great food resource when they're available to bears, but bears also use over 200 other food sources in the ecosystem here. So bears are opportunists, so they're going to eat what's in front of them. But in a good cone year, what you will see is that in the fall, I shouldn't say this in front of my mom, but I like to have more people in the fall when we're going up to the stands, because bears are up there checking them out. And they're just going to see if like, you know, is this going to be a good year for me to stay up here? If it is a good year, the bears tend to stay high in the mountains, which means they're not in human development, which means they're not near humans, because we all know, you know, a fed bear is a dead bear. So it does increase survival when the cone crops are good. The other thing that you will see is that higher fecundity. So there's more cubs born as well. So to the threats to whitebark pine, we have white pine blister rust, mountain pine beetle, and then climate, which is wildfire and drought. White pine blister rust is a non-native fungus. Again, it was introduced in about 1910. It really thrives in a maritime climate. So it just marched its way east. It did well in that area and started coming east, and it was discovered in the GYE in the late 30s and the early 40s. And since that time, blister rust has hammered white pines across the continent. So if you go to Glacier, which is more of a Pacific maritime climate, there's like 10% left. So they really suffered up there. What you're seeing in these photos are active Acacia spores in cankers. We call it Cheeto dust because it looks like the dust from Cheetos. But yeah, they're just blistery, and typically we'll see these mid-June. They kind of erupt mid-June through late July, but we're actually starting to see a shift, which is interesting. I don't know if it's with climate. But the thing about blister rust, it's a very complicated life cycle. And a lot of that's because it also has to complete, it's got 5 spore stages. 3 of them are completed on an alternate host. So what happens is the 3 stages, and the alternate hosts are the currants or like gooseberry. There's tons of varieties out here, and they do well in disturbed areas. So the hosts are everywhere. And then we also have paintbrush and lousewort. But the 3 stages form on these alternate hosts, and that final stage, when it matures, it'll hang underneath that leaf. And the reason I'm always surprised this has done so well out here is because they're super sensitive and fragile. So there has to be like exact amount of humidity and temperature and time for these spores to actually transfer from the host to the tree. So when that happens, then they're called basidiospores. They go to the whitebark pine, they land on the needle, and then they go in the stomata of the needle, and then they'll travel down the branch. And then on the tree, they go through 2 phases, and those Acacia spores, those Cheeto dusty ones, was the second one. Those, again, they wait for the right humidity and temperature, and then they are transferred back to the alternate host. So it's this cycle, and it just keeps going. Whereas mountain pine beetle, I'm sure folks are familiar with mountain pine beetle and that their superpower is eating through forests of trees. They just can decimate a forest crazy fast. So they're native to our western forests, but most of the time they're present at endemic or low levels. So lots of things will kill trees, like lots of pests and pathogens, but these slides are really specific. These photos are specific to mountain pine beetle. So in the upper left, that is an attacking beetle. And what happens is beetles don't have a real good directional flight. They just kind of go out there and fly, and then hopefully land on a tree that they want to eat. And so a female will land on a tree, and she has to decide whether it's worth the risk to actually start trying to attack this tree. And if she does, then as she's digging in, she has this like come hither beetle perfume. It's called a pheromone, and so she's trying to attract other beetles, because the only way for these beetles to overcome any tree defenses is by having tons of them attack a tree. It's called a mass attack. So it looks to me like when we took this picture, the tree had probably already been attacked by other beetles, and it's got nothing left. So a lot of times you'll see them pitching out these beetles, and they'll be caught in these little pitch balls, but this tree's doing nothing, and that beetle's just going to get inside. Once inside, the female will lay her eggs in these vertical chambers right here. So the eggs will hatch, and then the larva will start feeding in the horizontal chambers. And these chambers actually really stop the flow of nutrients in the tree too. It kind of girdles the tree underneath the bark. So when we have dead trees on our transects, we always peel the bark, and we're looking for this signature J. This is mountain pine beetle. It's got a signature J gallery. Nothing else does that. So we know that the tree was attacked by beetle. The other thing that happens is when the beetles enter the tree, they carry this blue stain fungus in their mouth. So when they hit the sapwood, that fungus leaves their mouth, and really fast, it starts traveling towards the pith of the tree. And that is probably what stops the flow of nutrients the fastest. So it's kind of a symbiotic relationship, because then if there's no water flow through the tree can't pitch the beetles out. So it's really advantageous for the beetles to carry this. Doesn't hurt them. It's pretty light, I suppose. And yeah, and the tree really can't do anything. So this is characteristic, this blue ring. And I actually brought a lot from my wood pile here, and you can see it's kind of faded, but it's better. But you can see the rings. And there's also some jade galleries there and anybody wants to look at them. Probably look, yeah, those of us who have wood stoves are really benefiting from this. They're easy to find. So, yeah. There we go. That's all I can say on that. Okay, so basically, in as little as 2 weeks, a successfully attacked tree is functionally dead. Sometimes they can fend off beetles and it's just a strip attack. But to date, there are an estimated 350 million dead whitebark pine trees out there, and that's more than the number of live whitebark pine. So, so why is the National Park Service vested in the health of whitebark pine? And as I mentioned at the beginning of my talk, whitebark pine was identified as a vital sign by the network I work for in the in Teton and Yellowstone in the early 2000s, which coincided with the GYCC subcommittee, the Whitebark Pine subcommittee, their need to get a better understanding of the health status of whitebark pine across the GYE. So we collaborated with the Forest Service and the US Geological Survey, and then also this wonderful statistician, I hope he's out here listening, Steve Cherry from MSU, to develop a robust monitoring program, and we with a peer-reviewed protocol. And that was finished in 2003. And a protocol is essentially just a recipe book. And this tells us how to collect the data, analyze the data, report it out, and then how to stewardship our work. So boots hit the ground in the summer of 2004, and this summer will be our 21st season. So this is the only long-term monitoring effort tracking the health of whitebark pine across the ecosystem. So my daughter was an infant when I started. Now she's almost 21. Okay, and bear with me on this slide. There's a lot of information, but so I just want to talk a little bit about the work that I do. So again, the Interagency Whitebark Pine Monitoring Program is a cross-jurisdictional multi-agency effort, and we span over 3 states, so Wyoming, Montana, and Idaho. The products that we provide are trends in whitebark pine health across this entire ecosystem, and it's supported by a long-term data set, which is pretty amazing because we have 20 years of data on these trees. And because we're out there every summer hiking hundreds of miles and all over the place, we are essentially the eyes in the forest for the land managers. They can't get to everywhere, but we kind of get everywhere. So we are always reporting back on things that we see. We're kind of like the first defense. We see something odd and we can report it out to them. With this information, they can really make data-informed decisions for forest management practices, like including restoration or protection or any other kind of mitigation. This also can help them secure funding for specific projects on whitebark pine or any other species that we're looking at. The data we've collected was also used by the US Fish and Wildlife Service to assess the status of listing for whitebark pine. And the data is publicly available. And we provide it to university students and any studies and then any other projects that are requested. So this map shows the distribution of the transects. We have 176 transects over the ecosystem. And at a survey, we'll record, so the trees on these transects are already tagged with these little $50 size tags. And when we go back in and visit them, we visit them every 4 years. We are looking to see if they're dead or alive. What's the blister rust status? Is there any insect attacks? Do they have cones? And then any other health issues, we document all that. And based on the data we've collected so far, we estimate that 34% of whitebark pine trees greater than 1.4 meters tall, we're only really talking about trees that are this and above, are infected with white pine blister rust. And 32% of whitebark pine, again, that height and above, have died since 2004. So I just want to kind of as an example of some of the data that what we can get out of some of the data we've collected. And this has to do with that mountain pine beetle outbreak. It was good timing for us. We started in 2004, just when the beetle was starting to kind of rear its ugly head in the southern part of the ecosystem. So we didn't see a lot on the trees the transects that we were setting up. But as you can see, kind of over time, it's called incipient. So it was building, the epidemic was building. And specifically, I want to look at this 2006 to 2008. So this is kind of complicated, but we'll get through it. So, okay, volatinism refers to the number of generations or brood an organism can kick off in a 1-year cycle. So, and then growing degrees, which are on the y-axis here, that refers, it's a measure of heat accumulation in a year, which influences development of insects, plants, and animals. So a lot of farmers or horticulturists will use that, and they can determine yield based on those numbers. So in the past, mountain pine beetle have followed what's called a semi-voltine life cycle. And that means that it took more than 1 year to complete a life cycle. So from egg to adult, it was more than 1 year. What we know about them is that they're super temperature sensitive and they can shift. Yeah, so they're super temperature sensitive. And what happens, so we tracked the growing degree days through time. And then we know that there's a threshold where beetles can shift to univoltine, which means they can complete their life cycle in 1 season. So the egg is laid, it develops into an adult, it flies, and they lay eggs again in 1 year. And what we saw, and then let's see, that line is just the peak of mortality of whitebark pine. So what we found was between 3 consecutive years, 06, 07, 08, we're above that growing degree threshold. So mountain pine beetle shifted to this univoltine life cycle. And like I said before, the only way they can successfully attack a tree is if there's a ton of them. So by synchronizing their life cycles, all of a sudden they had just masses of beetles out on the landscape. So in the past, when they're at these low levels, you don't need as many beetles to overcome tree defenses, because if they usually would pick a tree that was like sick in some way already, or you know, maybe there's some drought, something was going on. But because we had massive amounts of beetles on the landscape, they were able to attack healthy trees as well. So what happened then, so in that curve, that bell-shaped curve you saw going up, 09 was kind of right in the center, and then it started dying. The outbreak was waning basically. And if anybody remembers, in October of 2009, we had an early season cold snap. And that year, the mortality was incredibly high that summer. But this cold snap hit, and what happens is beetles have like an antifreeze they put on that they can cold harden, and it gets them through the winter. So they usually do it a little later in the fall. This cold snap hit early before they could cold harden, so they didn't get their antifreeze in, and probably killed a lot of them. And after that, this was from the graph before, we saw the growing degree days go down. We also saw mortality start to go down. So the other thing I wonder is that basically I said it was 32% mortality in this size, but it started in that size class of whitebark pine down here. But when we looked at the bigger trees, that the ones were in the canopy, and those are the ones the beetles really want to hit because they're just a better resource for them. They can kick out more larvae. So a big tree can support more babies basically. But they killed about 75 to 85% of those big trees. And so we also wonder, was it a combination of this cold snap that knocked back the beetles, as well as they ate themselves out of house and home? What we did see though, is because we lost all those bigger trees, we now have a shift to smaller sized trees in the ecosystem. And what we know, unfortunately, is that smaller trees, when they get infected with blister rust, they die sooner. So the blister rust has less length to get to the trunk or the heart of the tree. And those big trees, they might have like 10 feet to get down to the bole or the trunk of the tree. Smaller trees will die much quicker. And then the other thing is, so with mountain pine beetle in the past, the mountains, the cold mountains were really a refuge for whitebark pine. And they didn't really evolve with beetles. So they don't have great defenses basically. Whereas lodgepole evolved with mountain pine beetle because they're at lower elevations. So the cold was keeping the beetle at bay to these high areas. And now that we're warming, they can get up to these mountaintops. Similarly, we're seeing a lot more wildfire up in these high elevations, and they're just burning stands completely. So while blister rust can take out smaller trees, mountain pine beetle takes out the bigger trees, fire takes out everything. So yeah, there's a lot going on. And actually, a prime example of these stand replacing fires is the Millie fire that happened in 2012. I have horrible distance inside, but it's south of us, where south is. And it burned over 10,000 acres, and a lot of those ridge lines were pure whitebark pine, and they're gone. We have 5 transects in that area, and we still go back on our rotating cycle, and there's nothing there. There's some forbs and grasses coming in, but it's fried. It was pretty intense. So, what is the future of whitebark pine? So there is natural regeneration happening out there, but, I don't think is it fast enough, and what is enough? Like, this is a landscape scale. So we really don't know. But, what are we doing about this? So there are some things happening, and one big win for the Loraxers, or the people who speak for the trees out there, was whitebark pine's listing in 2023 is threatened under the Endangered Species Act. And actually Canada, Jill, they are much more progressive, and they listed whitebark pine as endangered in 2012. And in Canada, there was a ski resort a couple years ago that cut down 120 whitebark pine to widen their runs or whatever, and they were fined $1.2 million. So they take it really seriously. So yay, Canada. Oh, and I don't know if anybody's curious, but like the difference between threatened and endangered is endangered means that the species is becoming extinct throughout or in significant parts of its range, whereas threatened means it's likely to become endangered within the foreseeable future. So that's the difference in that listing. So more policy things that are going on. The subcommittee, the Whitebark Pine subcommittee, put out this strategy in 2011. And it's basically to conserve and restore whitebark pine populations in the GYE. And now we have a national strategy, and this is like the GYCC strategy on steroids, because this is multi-agency, multi-park, multi-state. It's just there's a lot of people who have their hands in this one, and it's in a draft form still. So some more tangible things that are going on. For several years, we have been collecting seeds from trees that might be blister rust resistant. And they're called elite or plus trees. And what happens is you go in and you go into a really highly infected area, and you look for a tree that doesn't have a lot of infection. So you take the best of the worst. And then they go in and they put cages on top of the cones in the spring so they're not predated. They collect them in the fall, and then these cones are sent to the Coeur d'Alene nursery where they're grown out. And then they're subjected to some just really intense testing. So they'll try and infect them with blister rust. And if they get it, then they get pitched out. But they have been successful in finding some mother trees that actually seem resistant. The other great thing that's happened more recently is this genome sequencing. So they were able to sequence whitebark pine out of Oregon. And it's the first step in creating a genomic tool that can rapidly screen trees for disease resistance and then climate adaptation. And with this information, we'll be able to expedite the supply of resistant seedlings for more cost-effective restoration. When they go to the Coeur d'Alene nursery, it is so time-consuming and expensive to test these cones that have been sent in there. So this will speed that up. The other thing that's been happening a long time is just general restoration of burned areas. So the trees that they're planting there, we don't know if they're resistant or not, but we're just trying to get trees back out on the landscape. I'm a big fan of just planting because I feel like we're kind of behind the curve and we just need to get trees out there. It takes a tree in this area about 65 years to produce a cone. So, and it has to get to that point, and it has all these threats that can take it out before it even gets there. So the other thing, MSU has some great greenhouse studies going on in Dr. Danielle Ulrich's lab, and there's probably some other that I don't know about in other universities. We're continuing the monitoring that the folks I work for run. There's public education like this evening, so thanks for having us. And then the other wonderful thing that Kyle is here to talk about is the Little Bear Orchard. And I just want to mention real quick, the Salish Kootenai tribes have a really robust restoration program as well. So they have an orchard up there and they're trying to restore tribal lands. With Kyle. So,
So I'm Kyle Marvany. I work with the Bozeman Ranger District of the Custer-Gallatin National Forest, currently in recreation. But I'm here tonight representing our seed orchard with the blessings of Heidi Janito, who's our seed orchard manager. Couldn't be here tonight, but I worked for Erin for 4 years doing whitebark pine monitoring. Had a lot of fun getting to run around all over the greater Yellowstone, and including getting to help out in the seed orchard one day. So Erin mentioned how there are identified elite or plus trees throughout the region. This is kind of the end product. We're trying to breed trees that are genetically resistant to white pine blister rust. So our seed orchard up in Little Bear Canyon, we're trying to raise seeds that have this genetic resistance from grafts, kind of similar to how an apple orchard works. Graft, we are harvesting branch tips off of these mature plus trees, grafting them onto rootstock, growing them for a short period in a nursery before transplanting them to our orchard, where we will then be able to harvest our whitebark pine seeds before that 65-year window in a couple years. So I think Erin mentioned a number of these documents. This is just kind of the framework for how we got to where we are now. So the whitebark pine genetic restoration program for the Intermountain West, whitebark pine seed procurement plans for 7 forests and parks. So think Grand Teton, Yellowstone, Custer-Gallatin, Helena Lewis and Clark, Beaverhead Deer Lodge, Caribou Targhee, Bridger Teton, kind of all our surrounding federal lands. This makes up the Greater Yellowstone, Grand Teton seed area, so that we're working with seeds that are adapted, trees and seeds that are adapted to this particular environment. We want to give them the best chance for success. So they have genetic traits that allow them to succeed in this climatic area. And the ultimate goal is for an orchard like this to be able to provide seeds or seedlings to seed 900 to 950 acres per year within our seed zone. And so the need for the seed orchard, it's very labor intensive and difficult to collect these seeds off of wild trees. We don't necessarily have any degree of control over what we're getting. Could get a mixed bag genetically. They might not be as resistant as, the end result might not be as resistant as the plus tree was. And it's a labor intensive process of caging the cones, going back and harvesting the cones when they're mature, and on and on and on. So a lot of work, much easier to just focus it all into a seed orchard, and then the Forest Service's nursery in Coeur d'Alene, Idaho. So within our region, there are about 235 plus trees that have been identified starting in 2001. This is also a pretty labor intensive and time consuming process, and work with some people who are trying to figure out how to identify some more, and it's a pretty intensive process. We started collecting pollen from these trees in 2009, with the goal being to use pollen from the plus trees to pollinate our trees in our orchards, so that we're getting a mix of genetically resistant trees, not just whatever background trees might be growing in the forest around them. The site was selected in 2009. It was cleared and fenced. It was an old clear cut area. It was clear cut in the late 80s. It was re-cleared and fenced in 2011, and planting started in 2013. So there's 7 acres in the primary seed orchard with space for 512 grafted seedlings that represent 32 genetic individuals. So 32 of these plus tree families with 16 of each of those. And they're organized into high and low elevation groups. It's all very mapped out. I don't have an exact map in my presentation of what that all looks like. There's an additional clone bank, which has space for more family representation. And then there are some additional test plots and holding areas. It's all drip irrigated. We have been fertilizing it in the past. We're stopping that because we think that might be causing issues with gophers and attracting them in particular. That's been a big issue in the seed orchard is gophers. And then as the trees get more mature, supplementary mass pollination with that plus tree pollen. So here's kind of what it looks like. The orchard is outlined in yellow there, clone bank in blue. This is way, way out in Little Bear. You can see in the middle of the orchard here, this is the irrigation pond. It's really just a water source. They pump water from here up to some holding tanks above the orchard that then allow irrigation to all just be gravity fed. So with a small pump, you can fill the tanks and then run a gravity feed out into the orchard, into the clone bank. It's all gated off. We have had some, I'll get into that. We have had some issues around that recently. But this is way, way out on the Little Bear Road. It's like 15 air miles, but it takes almost 2 hours to get there. And as Erin can attest, it's one of the rougher roads around. It's just very, very bumpy. So this is what it looks like up there. This is looking, so this is at the top of the seed orchard, uphill and up here. Looking out across Gallatin Canyon, you can see Gallatin Peak in the back and Storm Castle and Garnet Mountain down below. And the rows of trees are kind of all oriented like a herringbone pattern off of that central road. So a chevron type shape. And then this is what they look like down on the ground. So these are freshly planted seedlings. You can see the drip irrigation. We build little micro habitats around them. So using logs and debris, woody debris to shield them from the most direct sun so that the soil can maintain moisture. So the trees are always situated on the north side of these little piles of debris. So the challenges, wildlife, that's why we have a fence. Gophers have really been the big challenge there. One thing that we've been trying to manage that is we put in raptor perches to give hawks a place to land and hopefully hunt a lot more. There's a little bit of vegetation management that goes on in terms of just kind of weeding things out and keeping other competing species from growing within that seed bounds of the seed orchard. Big one lately has been vandalism and theft. We had $7,000+ worth of equipment stolen out of the orchard this summer, and it's been pretty time consuming to get that sorted out. I don't know that that's been remedied, but we're doing everything we can there. Let's see. Oh, I guess this is going. So yeah, I guess where we're at with the seed orchard now, it is 70% planted. So 70% of those available spaces for grafts have been planted. Some of them are starting to produce cones and we are collecting them. We're just not yet shipping them off to Coeur d'Alene. So ultimately, we will harvest cones in the fall, cones and seeds in the fall. That will get shipped to Coeur d'Alene, where they'll get stored, and then some of them will either be used for direct seeding, so just planting the seeds directly into the bare mineral soil, like a nutcracker would, or they'll be grown into seedlings and then shipped out to be planted after 2 years. And that's kind of the same sort of process that the grafts go through. We harvest the scion from the trees, it gets shipped Coeur d'Alene, grafted onto rootstock and grown in the nursery there for 2 years before being sent out to orchards like ours. The Helena Lewis and Clark has another one. I think a lot of the forests now are starting to develop these sort of things. So that's about what I have. I guess one last note, Erin mentioned the Millie fire, the Whitebark pine monitoring sites that are up there. I've been to a couple of them and they are just dust, but immediately adjacent to them, there's actually a significant amount of planted whitebark pine. Not from this seed orchard, but from the Coeur d'Alene nursery. So the Forest Service is actively working to replant these disturbed areas. And that's part of that goal with the 900 to 950 acres worth of planting per year, is to be able to provide that.
Thank you so much, Kyle and Erin. So interesting. We now have open floor to questions. So just you raise your hand, I'll bring the microphone with you.
So I have a question about the blister rust. And you talked about the cycle with the alternate posts. So the fact that we've lost so many whitebark pines, does that break the cycle in that area?
No, I mean, there's still plenty of smaller trees. And the other thing is that those alternate hosts are everywhere. I guess one thing that we see is the trees up higher don't tend to be as infected. And I think part of that is because they don't have a local source of rust yet. So they're relying on the lower populations and there's like a pretty healthy population of local rust and there's ribes down there and the cycle's going on and that can carry the spores up high. And a lot of the higher places, we don't see as much ribes and stuff. So if you don't have the alternate host, then you're not going to have as much rust. But we were seeing the rust increasing actually in some areas. So there's a tree can become infected and can be functionally dead, but it can take decades for it to completely die. So it just has to travel down the trunk, but there's still green branches and those spores are still getting kicked out. So we haven't really, if anything, we're seeing it kind of increase, I'd say.
And then just a follow-up on that, regarding nurseries, would there be any advantage to having a nursery, for example, in eastern Montana, where there's no exposure to the blister rust?
Well, I think the main reason is we want to be growing these trees in the environments that they're adapted to. These are not prairie trees, whereas you might be able to.
That.
Yeah. And that's why, like the seeds that we're using in this particular whitebark seed orchard are all sourced regionally. They're coming from this Grand Teton, Greater Yellowstone ecosystem. You couldn't take seeds from Glacier and expect them to succeed in this seed orchard here. So
So you actually want the trees that are in the orchard to be exposed to blisters?
No, so part of it is it's an elevational gradient. So what he's saying is like, you have to grow those trees where they came from. And so, but hopefully the trees that are in the orchard are blister rust resistant.
Yeah.
So that's the idea.
And so far that's holding true. These, there's rust in the trees in the wild around the orchard, and the trees in the orchard, apart from the ones being eaten by gophers, are healthy.
Thank you. We'll take another question here.
Yeah, I have a question. From what I understand, the blister rust and pine beetle, they've been on the landscape since the beginning of time, I assume, right?
Not the rust.
That's
The
right.
rust was just introduced in the early 1900s, yeah. But beetles, yes, they have evolved with, lodgepole pine, more, so they've been here forever. But the problem now is that now they're able to access these higher elevations. And whitebark did not evolve with mountain pine beetle as closely as lodgepole pine did. So lodgepole pine have much better tree defenses to when a beetle's attacking, they can pitch them out much better. And it has to do with all these chemicals in the trees. Whitebark pine is not so great at doing that because they didn't really evolve with them the same.
So with that in mind, I take it that it is probably the fact of climate change that is making this worse than what it has been.
Yeah, because now they're able to reach those high mountain sites. It's not as cold up there. And then also it's that whole the life cycle, the semi-voltine versus the univoltine. When it's semi-voltine, you never get a ton of beetles at the same time. They're kind of off, like one brood finishes here and the next one's here. You don't get this whole conglomerate. But when they're to univoltine, which is temperature dependent, then you got everybody out there at the same time. So they can synchronize their life cycle.
Rich, do we have any questions from online, and then we'll come back to our in-person questions?
Okay, a couple from online. First, Michelle asked a couple questions about the possibility of management in the forest. For example, can the blister rust be pruned from trees? Can beetles be deterred with pheromone traps?
Yeah, so all that can happen, but on a landscape scale, it's just too much. So if you have like a monument tree in your yard or something like that, that's doable. When you're talking about thousands and millions of trees, it gets a little harder that way. So they did in the 1950s, they knew that the alternate host was rabies. And so when the soldiers came back from the war, they were looking for work for them, and they sent them out in these rabies eradication crews, and they were pulling and spraying and burning and all this stuff. And there was just no way. And there's so many. So it's just about the scale. You can cut it off, and they used to do that in the Forest Service, but yeah.
But for example, it is practical to go out and put pheromone packets on plus trees. If we're worried about beetle attack. And I believe Verbenone has been fairly successful in 5-needle pines at keeping beetles out.
And in campgrounds, like you'll see those pouches on trees in campgrounds. So for a few trees it works, but not for a full forest.
With the nursery, if the natural age to bare cones is somewhere in the area of 65 years, how much faster can we do it?
Well, I mean, these trees, they started planting in 2013, and they found some cones this past summer, so less than 10 years.
They got 60 cones. So the scion that Kyle was talking about is from a mature tree. So they grow the rootstock. It's like, I don't know, pretty young, like 3-4 years old. They graft it on, and then it kind of tricks the tree into thinking that it can make cones. So that's why they're able to make cones when they're really small like that. Yeah, it's really cool. It's amazing science. Yeah.
Thank you. We'll take another question here in the audience.
I have a question. I've done a few aerial flights looking at whitebarks, and I noticed in the Madison Range, tremendous amount of kill. We did the lower the southern end of the Madison Range. I mean, I could say 80% dead. So now about the grizzlies that come out of Yellowstone right across 191 is the Madison. The whitebarks used to be one of their top 4 energy producing seeds, and now they have to go for others. Like for example, in Douglas fir, seed capacity, our food value is 10% of the white bark pine seed. So what does that mean for the grizzly? They just have to move away, move, move, move. And, the expansion does not seem to be well tolerated in the state. I think that's just basically a question, a statement.
Yeah.
But
Yeah. Yeah, it's, I mean, they have shifted foods, so the grizzly studies co-located in our offices, and so I get a chance to walk down there and talk to those folks about it all the time, and they put some papers out about it. And some of the recent work is showing that they've actually shifted to carcasses a lot. So, again, I know they eat like 243 different foods. So they're real opportunists. I'm sure everybody's heard about the wild caraway up Tom Minor. I mean, that just came in like 10 years ago, and there'll be 20 bears at a time. Like, it's like watching cows, basically. So they're smart and they're opportunists, and they will find other things to eat. But yeah, moths, they love moths.
At what elevation is the seed orchard?
Just over 8,000 feet, 8,400, I believe.
And why is there a fence around the tents in the slide?
Oh, I put that one in there because, so that is a bear fence, and I just decided it's like a sleeping placebo. I don't really know if they work, but we haul them in there, and this was in the South Fork of the Buffalo, which has a lot of bears. And I love the picture because we're just in the middle of nothing, and I put my shoe under my backpack, and the only thing that breached our security was a chipmunk. It filled my shoe with dandelion. I thought it was so funny, but it's just their electric fences, and it makes me feel better. I kind of sleep better. It makes my mom feel better that I have it. I think.
Okay, another question here in the audience.
Hi, I was gonna ask you some questions about limber pine early, but then as you went on your talk, you answered.
Oh, okay, cool.
Correct. But I have a couple.
All right.
Since whitebark and limber are so closely related, and since they occupy similar types of habitats, just maybe some difference in elevation, do you think there's potential as the climate warms, and especially in the upper subalpine, it gets drier, that limber pine will keep moving upslope?
Sure, yeah, that can happen. And then also what we're finding is whitebark lower. So on BLM land, they're actually finding whitebark way below 8,500 feet. So I think maybe that might be another resource, is like these open fields that they love full sun, and so they do really well. There's some places outside of Dillon we were working in last year, and we were finding whitebark below the limber. So I think it could go either way. And again, I said latitudinally, as you go south, you find limber pine much higher. So it's above 10,000 feet down there. So they're mixing at these really high elevations. So, that's one thing a lot of people are talking about, is should we start trying to plant whitebark pine lower? It might do okay.
Yeah, so I was just wondering if maybe then over time, limber pine may occupy the same niche where whitebark pines disappear.
Yes, I think, I don't know if I'm allowed to say this, but we always call limber the bastard stepchild, because like nobody seems to care about it as much. There are some people, but
It's facing the same issue.
yeah, totally same issues, but it doesn't have that cone. The cone is kind of the golden ring, like those seeds for the foods and all that kind of stuff is, I think, why people care. And whitebark are higher. I mean, our mountains are our water towers. And, we used to really hang our hat on that whitebark pine really stored all the snow, but there's been some research at MSU that's finding that they're probably not as important as we think, but they still do trap snow. And they have other services up in the high elevation ecosystems. And again, they provide surface area, so they will catch snow. Those islands allow those other trees to come in and they catch snow too. So, they're just, we'll see. We'll all be dead by the time, it's up there, but yeah.
First of all, great talk.
Hi.
Kyle. And when you're talking about like caring about the other trees, if I can word this question, it's like a feeling I have. I'm super grateful for all the funding that's gone into this over 20 years. And I'm
So am I.
wondering if it's because it's with the park service. And if it's because it's a keystone species, maybe you could elaborate on that a little bit, just like, how come white bark pine is getting so much attention? And how can we get more attention on the species like the cottonwoods in our backyard? You know, like how can we get some of this excitement going right here around us?
Yeah.
If you have any suggestions or ideas, but.
I mean, again, it was identified as this vital sign here for high elevation ecosystems. So that was really why it was selected by the Park Service and by the network I work for. You know, and then, yeah, it's important up there. Cottonwood are important too. You know, there's a lot of research that goes on with aspen in the parks. And I know that like on the Forest Service, they're losing a lot of aspen stands. So they're doing a lot of work in those. So it's about keeping our ecosystems intact. And whitebark pine's really key player in those upper elevations. So, you know, not just for the services it does, but just we want to maintain these intact ecosystems into the future.
Thank you so much. I think we'll take one last question. We're running out of time here.
Thanks for a good talk. You mentioned post-fire mortality of whitebark, and I was wondering if you could talk about regeneration after fire, and how much do you think that fire was part of that high elevation system?
Yeah, so you know, the fire, we talk a lot about these fire disturbances being managed now over the last 100 years, and that probably hasn't been great for whitebark pine forests. One thing I nixed off my slide was competition's also an issue for whitebark pine. So when they start to get overtopped by these other trees, then they don't thrive because they want to be in the full sun. So in the past, fire has taken out the competition basically. Whitebark pine tend to have a thicker bark that they're protected from low intensity, even to mid intensity fires. And so we tend to get these really massive fires now, right? And they can't really survive those. We're also realizing, like, you know, we really want to keep every cone producing tree we have on the landscape. And so Bob Keene in the fire lab up in Missoula, he's done some work, and even some of these low intensity fires do damage those cone producing trees. So it's probably not as popular as a management tool anymore. So I think going in and cutting, thinning out trees manually is probably the way to go. But in terms of, did I answer the question or
Regeneration.
okay, so the region depends on like the intensity of the fire because it can sterilize the soil. So seeds can stay viable in the soil for about 10 years when the Nutcrackers planted it. But if the fire's too hot, it's going to fry everything. We have a site that's up Mill Creek near Immigrant. And it was established in 2007 and then it burned 2 months later. So I started going back in there. And is Mary here? My poor friend Mary's gone up there with me so many times. It stinks going up there, so I always run out of volunteers pretty quick. But so I've been going in, and I was really curious to see when I'd start seeing seedlings happen in that area. It's only one stand, so it's like very anecdotal, but it took about 6 years for any white bark to start regenerating in there. There's still intact white bark up the hill. It's right under the pyramid up there. So there's a seed source, but it took about 6 years, and I've been going back in every single year and measuring, like counting new ones, measuring the height, and yeah, it's really slow. So some areas, they like full sun. That's the bottom line. The places that we find a lot of regeneration are usually like post logs. You know, they've been logged, and so like 100 years ago maybe, and you see tons of them in there, like 500 in that 10 by 50 belt transect. So I think a lot of it has to do with sun access for when they'll come back.
Or even like where there's pockets that flow down.
Yep.
stuff like that.
Yeah.
Well, great, well, thank you so much. I think we're and, I just wanted to, thank you all for coming. And, I just wanted to let you know, those that have attended online, you'll be receiving an email in your email box with a link to a recording of this talk. So you're free to watch it again or share it with other people. Well, a recording will also be out on our website shortly, so all of you who, if you want to share it with others or watch it again, it will be available there. Upcoming events are also listed on our website. Please join us for our next event, which is the economic impacts of a changing climate on our forests and outdoor industry. That's with Frank Solzy. He's the executive director of Montana Wildlife Federation, and that is on Thursday, February 22nd. It's online only. It's at 7 p.m. And we also have a talk coming up at the Museum of the Rockies, which is in person only, on Tuesday, March 5th. How can we better protect our community from future wildfires? We'll be showing the critically acclaimed film Elemental Reimagined Wildfire. And then we have some local experts with should be a very interesting panel discussion. And then last but not least, just remember, come out to our fun Earth Day Festival on Saturday, April 20th. Be lots of fun and more talks there. So thank you all for coming, and look forward to seeing you at our next event. Bye.